Right, so for the talk this evening, we've got Sean Wright speaking to us about weaknesses in software supply chains. Sean?
Great. I don't know if should I use the mic? Not use the mic?
No, use the mic.
Use the mic.
Stream.
Yeah.
Oh, right, okay.
Whatever. All right, if you can't hear me, I'll use the mic. I don't like using mics. So I left my introduction because I didn't want to do it twice. So just a bit about myself. I used to be a developer myself. A lot of Java, bit of C. Still sticking with some development. Trying to get into Python. Suck at it, but hey, I'm learning. Other things that I do is, so OWASP is a global kind of charity focused on security, especially around web applications. So we have a local chapter in Scotland. I co-lead that, so if you're interested, definitely look for OWASP Scotland. We're on Twitter, have a wiki page, have Eventbrite, so feel free to come along. It'd be great to see some of you guys there. I was the lead security engineer. This kind of changing, so I left it in there. I don't know what I am now, but my role's changed. And I do other security stuff. So I do a lot of stuff in my own time. I do a lot of researching, personal stuff, and I do this kind of thing, giving talks, help people training, trying to get into workshops. So that's just a little bit about me. So what I'm going to talk about is nothing new. It's all known. It's all stuff that's already been done. But I do see a bit of awareness being raised around this topic, but I don't see enough. And the guys like yourselves who are developing systems and that, I think, are perfect audience for this, because you guys are the ones taking these software libraries and building things. So it's always worth keeping this in the back of your mind. So I like to take a step back and view how we used to do software development versus how we do it today. So if you take a step back and your more traditional software development lifecycle was a big monolithic release with lots of modules thrown together in one massive release. Now this is great from a security point of view because, hey, I know there's going to be a release on date X. I can plan my security checks, testing, reviews, all for that date. Yes, I might have limited resources, but I can pull them off other things and get them focused on the release. Today, that's no longer the case. We build things in a modular fashion, whereas in the past we probably built things from the ground up. And this is where the software libraries come into. I view software today as more gluing things together. Obviously not always the case, but a lot of the time it's taking libraries here and there and putting them together to generate or create a system or service. In addition, we have DevOps, the whole CI/CD model where releases are continuously going out and different sizes, different types of releases. So from a security point of view, it's difficult. How do I know when a release is going out? When do I need to allocate my security resources? I need someone looking at this full time. And security departments are often really under-resourced. So we need to kind of adapt to this model and start including checks into how we develop software and how we include, more importantly, how we include libraries in there. So I've already covered, like, we do rapid deployment, CI/CD, and security teams just aren't able to keep up. There's just so much going on. And I'll show you now, like, doing any of this manually is just not going to work or scale. And this is a report from Sonatype. So Sonatype are a company that is heavily invested in tools around third-party libraries and integrations in your SDLC. So anyone familiar with MAVEN? You probably know Sonatype. So MAVEN is a for those who don't know, Maven is a library management primarily aimed at Java. So Sonotop have a repository that they provide for Java and Maven repositories. So they produce an annual report. And the 2019 report, there's some numbers there, but as you can see, there's just a staggering amount of software being released in terms of libraries. I mean, the first line, there's like almost 8 million open sources releases a year. That's just huge. The amount that each enterprise is downloading is also quite staggering. But perhaps more worryingly is the increase in open source related breaches. And you can see this at the end, some of the repercussions of this. So when looking at your software supply chain, I kind of see 3 variants of this in our modern day software development lifecycle. So you have services. Services must probably be more geared towards your web applications. So, I don't know, an online chat service that you integrate with. You'd have some of their software that you'd integrate on your website. Primarily, probably JavaScript. Libraries, well, this is, as I mentioned, most of what our software is comprised of these days. And then containers is obviously becoming a bigger and bigger thing. So things like Docker. And this is a very early and new technology that is really showing some of the risks associated with it and some of the tooling that we need to get in to prevent those risks. And when I take a step back and look at your security issues with software, there's basically 2 types. So someone's developed something and created a flaw by accident, and I term that as a vulnerability. It's unintentional. And then the other is malicious. And I'll get into the malicious part a bit later, because the vulnerability part is, we all know this, it's kind of well handled to a sense. The malicious part is not well handled, and it's probably the most dangerous out of both these 2. So, thinking like a bad guy. And you also got to remember, bad guys that operate like a business. They're going to want the most data, access, whatever, for the least amount of effort. They're going to operate on like a profit model. So when you typically look at the way attackers used to work and our whole environment, used to be strongly guarded or fenced around, much like a fort. You have all your perimeter checks and balances in place. An attacker has to try to break through that. It's pretty difficult. So some of the ways they used to do it, used to find a known weakness, common vulnerability, exploit that, get in. And then once they're in, they can execute a payload. So payload is they trigger some sort of logic flaw or whatever, bug, and that allows them to run a command or whatever to be able to get what they need. So typically a shell or command prompt. And then they'd use that to pivot. So they're on a box somewhere in your internal network, and then they can go around. Because generally, once you're on your own network, you can go from box to box to box quite easily. Not always the case, but often the case. So the point with this is, it's very targeted. You have to find a vulnerability. You have to know that it's exploitable. You have to know that you can then get a payload executed and access to that payload, which is not always that easy. So if I was an attacker, which I'm not, I'd think like this: Prison Break. Here's the way of Prison Break. Okay, so it was really popular. Perhaps it's showing my age. So Prison Break was a series where the guy's brother got incarcerated or imprisoned. I don't know if that's different terminology. But he got imprisoned, right? And he got in prison for a crime he didn't commit, and his brother wanted to help him out and get him out. So his brother could have smashed through the prison with a, I don't know, a big, huge truck and try to drag him out and do a police chase and all of that. No, he chose to purposely get imprisoned himself and then work with the prison, trying to turn people and that to then escape. So working from the inside out. And this is the way I've used software supply chain. While try to bash through the wall, make a lot of noise and get caught, when you can get yourself in and then work your way, you have a way out. But it's also important to note that you need to do it in a methodical process. So again, relating back to that series, he didn't just go in day one, okay, I'm going to work to get my brother out. It took months of planning to eventually do the final prison break and then get his brother out. Similarly, when you're trying to do this attack, you want to create as least amount of noise as possible because you want to be on that network as long as you can. So some of the things that you would do is perhaps have a time or event based. So while someone might review this library when they first do it, see nothing suspicious, suddenly when it's in production after date X, it executes, opens up the connectivity. The reverse payload, most organizations are looking what's going in or blocking what's coming in. Very few are actually monitoring and preventing things going out. Now, there are things like DLP, which is data loss prevention. They don't work generally, in my opinion. But the general premise is that. Also, IP-based. A lot of security tools rely on bad host names, URLs, in order to detect something's wrong. If you make it IP-based, they kind of don't work. And also, by using IP-based, you're making less noise, so there's less DNS lookups and all of that kind of thing. And like all good people and good security, even the bad guys need to do security, TLS. So TLS is really bad from a security point of view because you can't see what's happening. You can't see what's actually going out. So that helps the bad guys because they can hide what they're doing. So that's the premise. So coming back to why this is going to be so easy to do. So these are some tooling around MAVEN, all right? So that there is part of the dependency management of MAVEN, defining what dependencies you're including in your project. You give it a group and an ID, that's the way MAVEN works, and then a scope. Compile means it's included at compile time, test means it's only included in test binaries. But the general premise is you want this in a compile, and it will have a jar, because that's what Java works off for dependencies. But interestingly is the SHA sum. Now, MAVEN, what it does to check that the library hasn't been or is correct, it just uses a SHA. Now, SHA is a hashing algorithm. Anyone could modify one of these jars, generate a new SHA, and you can't tell that it's been modified because the SHA will be modified there. The point being is I can either modify this jar or even generate my own jar. There's no process in MAVEN by default to authenticate those dependencies. So I'm downloading from MAVEN Central. How do I know those haven't been tampered with? There is a PGP key, but it is not enabled by default. So any dependencies that you're pulling down, you have no way to validate the author of those, saying this is someone I trust. And this is how you would get on the inside. I would, and I think it's correct, I might be wrong, but I think anyone can upload to MAVEN Central. So either you would create a new library with a fancy gizmo that everyone wants to download, or you would modify one of these repositories. And in a typical environment, you have different repositories. So you have your Maven Central. This is where all your public dependencies are. And then typically on a build server like Jenkins, it would go through your private repository. Most organizations would have this. I would highly recommend this and not pull directly from the internet. There's obviously performance benefits to that as well. When Maven runs on any system, it generates its own local repository. So again, you'd have a local repository here. The point is the attacker can inject themselves, and if they can inject themselves into any one of these repositories, they can modify that jar, change the SHA that's associated with that jar, and how do you know that that dependency has been modified? You wouldn't. And then Jenkins builds it, deploys it, and it's in production. Worse, some dependencies some links, and this is Maven Central, still allows for plain HTTP connections. Now, HTTP is bad because if anyone's able to get between the server and your whatever's calling this, they can modify any traffic going back and forth. So again, attacker would modify the SHA sum, modify the contents of the jar. You wouldn't know. You'd have a bad day. And this is not just to Maven. I mean, this was correct at the time I did this a couple of months ago. It might have changed. I might have got some things wrong. So if you know anything, please let me know. But generally, some, like Maven, do have signature validation, but it's not on by default. And some have none. And some have manual. So you might be thinking, okay, well, this is great. Well, what if I just review the source code? Yeah. So I took this is just two libraries, right? The first one is from Commons Codec. So this is Apache's library. It has 8,361 lines of code. The other one is from Spring Security, and that has 15,739 lines of code. Two libraries. And you're probably talking about, I don't know how many libraries a project may have, but you'll have transitive libraries and so on and so forth. So you can see it's never going to scale. And let me ask you this. A lot of you are developers. Would you allow any other random developer to modify your code and then put their own code in your code? Anyone? Because that's literally what you're doing with these libraries. So this is just summing up some of the risks that I see. So as I said, there's no validation being done in some of them at all. Some of them are not turned on by default. So you can't validate the author. They might be doing a legitimate way, doing a legitimate service, or they might just be doing it in a way to get into the back through a back door. As I mentioned, you're literally including someone else's unvetted code in your environment. Some of them, especially from a security point of view, are not tested. And this is a common thing that I see quite often. So even if there are security checks, they're kind of done it at the time that you include it, and there may be subsequent updates, and no one ever looks at it again. There's also the misconception that open source is always secure. I've heard this argument being provided many times. Yes, it is, but as you've seen, just because it's open doesn't mean it's going to get looked at because of the sheer volume. It helps, don't get me wrong, but it doesn't mean it's secure just because you can look at it. So I've gone on a lot of things that are bad. These are some of the things you can do to try and minimize that risk. So there are some great tools out there. So Veracode does scanning of your code, but it also does checking of libraries that are included in your code. And it has a database of known vulnerabilities. It'll match those up and report those. NPM does the same thing. NPM audit does actually a really good job. SNCC I've not used, but it does a similar thing. Sonatype Nexus. Their free version I don't think does much. It's once you start paying for things, surprise. They have a tool called Firewall where you can set policies and only allow, or you can block libraries coming in that you deem above a certain threshold in terms of rating on security. I left the two last ones for these two last because in my opinion, these are excellent tools and they're free. They're part of OWASP. Dependency check kind of feeds into dependency track. Again, they'll scan your libraries, match it up to a version, known vulnerability, and then report on those vulnerabilities. Dependency check is kind of part of your build process, can generate XML, HTML. Dependency track is more a application that you can have a central place for all your dependencies, and you can report on them. It's really good, so I highly recommend having a look. So some other things to check. So if I'm including a library that, I don't know, is doing some codec check, right? But it suddenly needs a HTTP client to then talk out to the internet, that should ring alarm bells. So check your constitutive dependencies. If something is in there that doesn't quite make sense, doesn't mean it's bad, but it means you should just investigate it further. Keep an inventory, so things like dependency track, excellent tool for doing this. Where you can, verify signatures. I think Nexus, surprisingly again, the paid version does this automatically, or you can set it up. Continuous checking, so much like continuous integration, continuous delivery. Make sure you try and include this as part of that process and block where appropriate. Whitelist, especially for your production servers. You should know what services your production servers need to speak to and only allow those connections. And then there's some features that you can gain a lot of usefulness out of. So especially like web-based, CSP, content security policy, and sub-resource integrity. These are basically like firewalls type thing for your web browser. So you define what that page can speak to and what resources it can include. Or sorry, more define what resources it can include. So if anyone's tampered with the library or your JavaScript, it just won't work, and you probably get reports firing off to alert you. So it's important to also note that it's an ongoing process. So just because you reviewed it once doesn't mean you should never look at it again. Make sure it's constantly being updated. This is where automation comes into it. Detecting and monitoring, so if something's trying to talk to something that it shouldn't, that should set off a flag, have someone investigate, and update. I've seen this too often, and you'll see later on why. It's kind of a case, okay, I'll include this library and never update it. Everyone's going to include a Dilbert comic in there, I think. But yeah, automate. Automate wherever you can. It's going to help you. So as I said, update where you can. I do realize that updating is not always straightforward. It can be a pain at times. Some libraries are great at backwards dependencies. Some are not, Jetty being one of them. I spend weeks on that. So while it's all great saying update to the latest, just be aware that it's not always as simple. All right, so this is where it gets a little bit more interesting. So it's all very well talking about hypothetical. I always like to finish off with some real world type examples, just to re-emphasize that this can and has happened. So the first one was a library called BOOTSTRAP-SASS. It was a Ruby library. And in March 2019, it was downloaded more than 28 million times. There was a backdoor in it. Thankfully, this only looks to have affected around 1,500 cases or downloaded with that vulnerable version. And it was actually discovered by a developer. So you'll see a lot of these aren't actually being discovered by security researchers or tools. It's kind of someone notices something weird going on, they look at it further and then find something bad. Thankfully, this has been removed from the library. And a common thing is the changes weren't made to the source code. So, hey, here's the source code. You can review the source code. The changes were actually made on the repository. So it just hides it even more. Who's going to look at the source code, go, OK, that's great, and then try to look at the binary? Almost no one's going to look at the binary. So this was the actual payload. So what it did is it actually took a cookie, injected a cookie, and I'm trying to remember, I think, yeah, did a base 64 on the cookie, and then the payload was actually injected into the cookie, and then executed the payload from that cookie. Pretty devious. Again, another Ruby library. This one the news broke out in July 2019. So this was a library used to check password strengths. So a security-based library, you'd assume is secure, so potentially people might not look at it. Again, the vulnerability was not included in the source code, but in the binary. And this one was actually quite interesting. It pulled the payload from pastebin that then told it off, then told it to go and do its thing. So it was like a command and control server type thing. So yeah, it was downloaded 537 times. So these things are real. Bitcoin mining, latest craze, latest phrase. So one of this actually broke out on a Sunday, and there was a library called BrowserLoud. It's used for accessibility, so those with maybe visual impairments and whatever, I think, that reads out the text on the page. It was a JavaScript library. It actually wasn't included in many government organizations. And it was found that the JavaScript was modified to inject the Bitcoin miner in. This was found really quickly, but it was used more than 4,000 sites globally. Guess how much money the attackers made out of this one? No? $24. Bravo. BA. So between August last year and September last year, BA was attacked or breached. I'll use breached lightly because it was again a supply chain, although it's not very clear how the attackers managed to do this, but some JavaScript was modified by a group called MageCart. MageCart is a group of attackers that specialize in going after point-of-sale online payment systems. So they specialize in that to try to steal credit card details. And that's kind of what happened here. So they modified the JavaScript library. The potential fine that BA faces is around the cost of a Boeing 747, which is 183 million pounds. So potential, it's up. This is post GDPR. So everyone aware of GDPR?
Oh, yeah.
So this is post GDPR. So the file's probably, hopefully, got a bit of grit to it. It's gone through the RCO, so it's up for appeals and got to go on. So that's why it's potentially. So yeah, Mage Card again attack the S3 buckets. So they're really attacking libraries, especially JavaScript libraries. And what they're doing is looking for open S3 buckets. Because some developers put it on S3, which is fine. It's kind of like, I guess, a CDN in some sense. But they then not putting security controls around that. So yeah, everyone can access it, fine, but everyone with maybe an AWS account can modify it. That's a problem. So they're shifting away. I think they were more fine-tuned, trying to target people or organizations individually. Now they're kind of shifting for a spray and pray approach. All right, so I did mention containers at the beginning. This is a good example of where container vulnerability came in. This is a vulnerability, not a malicious one, unlike the others. So Docker Alpine, there's a container. Anyone aware of that? It's used quite a few things. Between version 3.3 and 3.9, there was no password for root. Yeah, root didn't have a password. So for those who aren't aware, no password for root means you could log in quite easily and get root privileges, which in the Linux world is
not entirely fair,
bad. So this was originally reported in 2015. It was fixed, tests were done, but then someone modified it, again in 2015. So someone fixed it shortly after it was reported, and then someone undid that fix. And that didn't that didn't get seen until 2018, so like 3 years. And it was actually reported, and it was actually only really brought up this year, the reason why it was flagged incorrectly. So this is, again, why it's so important to make sure that any sort of issue tracking you have around security stuff, make sure you're on top of it, because misreported things could be really bad. All right, so I saved the best for last, Equifax. I'm pretty sure everyone in this room has heard of Equifax. The details around Equifax is there's a Struts vulnerability. So Struts is a Java JEE framework, so Java Enterprise framework, web-based framework. There was a vulnerability around serialization. So serialization is where you take an object and you can put it into some string form, like a file or a stream that you can send over the internet, and then build it back up into the object. Now this vulnerability allowed for remote code execution. Bad. And look, in terms of vulnerabilities, remote code execution is probably the worst. This affected around 145 million US citizens. There's estimates, but 400,000 to 44 British citizens. I don't know how many that is, but the point is this hack is a really big one. They're still in the news, even though this happened in 2017. The news broke in 2017. Anyone wants to hazard a guess how much this breach has potentially, or has so far costed the company?
Billions and billions.
Not enough.
They've made money since then.
1.4 billion.
That's fines or?
That's fines, IR, so incident response, so getting guys in to look what happened, putting protocols and checks around the new security and all of that. This figure was announced before they were the first company that got a negative credit rating directly as a result of a cyber incident. So it's possible that amount's going to go up. I mean, a credit company with a negative credit rating, yeah. Now, the thing for me about this whole situation is, and I am speculating, it could have been a one-line code change. Think about it. It was a struts vulnerability. They just had to update struts. And as far as I know, I think struts is pretty good with backwards compatibility. So it's literally saying, hey, this version X, change it to version Y. It may not be the case, but hypothetically, it may have been that. So a one-line code change costing the company $1.4 billion, if not more. And they become the great example of how not to do security. So companies often do this. They will take a vulnerability and they'll say, not all companies will do this, but many will. So they'll go, right, so this vulnerability is going to take us possibly X amount to fix. Possibly if we get breached, it'll cost us Y. Is it worth fixing the bug? And that's a dangerous thing to play with because it's really hard to gauge how much it's going to cost. I bet you now, if Equifax did that evaluation if they did it, they wouldn't have even thought $1.5 billion. You also got now big fines, hopefully, with the likes of GDPR. And there's a whole moral aspect to it. So, yeah. All right, so.
Sorry,
yeah.
How many companies do you think roughly will play that gamble? Because it's not just a matter of development time and money, as in fines, protocols, and etc., but there's also a loss of image, identity, brands can suffer as well. So, I mean, any responsible company, I would imagine, will take that under account, and it's tough to put money value into how much a brand will lose that will be associated with a breach.
So, I mean, it seems counterintuitive. I've suffered a breach. My reputation should be in the gutters. Especially if I'm trying to hide it and whatever. A good example is Facebook, right? They didn't really, well, they did suffer breaches and breach again and breach and other issues. But where's their reputation? They're still making a ton of money. They're not suffering. So I think the whole industry needs to take a step back and reevaluate how do we deal with these things. Because trying to place it on a damage to a reputation, I don't think is going to work because it kind of says otherwise with the likes of Facebook. Equifax, you would think with the amount of stuff ups that they've had, they would be done for. But they're still able to pay $1.4 billion or whatever, and the fine was, I forgot the amount, but they got a massive fine as well. So yes, maybe sometimes it can. I think where it's going to impact companies the most is smaller companies. Bigger companies can easily ride it out. And there's even been studies where sometimes the share prices go up. Makes loads of sense. But yeah, it's a difficult one because that's why we're seeing it time and time and time again. And there's little changing. So kind of why I pinned my hopes on GDPR. I was hoping fines would kind of provide a disincentive, but we're still seeing the same issues popping up. So to close, conclusion, update your stuff. Obviously, it's not as easy as everyone thinks it is, but at least try. Try to get some automation in. Rely on security controls and features that are there. So with that CSP, so going back to the browser loud where the Bitcoin mining, if they had CSP implemented, the Bitcoin miner wouldn't have worked. And if you had reporting in place, you would have been alerted like pretty much straight away. So these two, if you've got web apps, especially CSPs, SRIs kind of falling away. If you've got web apps, definitely have a look at it. It can really, really, really help you out. As I said, automate, least privileges, kind of a fundamental security thing. Whitelist your production servers. There shouldn't be a reason why you can't. Monitor, flag up anything that shouldn't be happening, investigate it. And then, yeah, update. As I mentioned, Equifax is the best example of where you don't update and the repercussions you can face. So that's it. Any questions?
Great. Any questions? Yeah.
Well, that's a good talk, but I do have to pull you up in it. That was a good talk, but I got to pull you up in the Docker Alpine thing, because that was actually a bit of a non-issue. Because the thing was, you're saying, oh, the password wasn't set, and that's true, but there was actually no way to change the root user. I mean, there was no way to exploit that, unless you get to a really convoluted situation with installs of the software. But yeah, the other thing, the actual question I wanted to ask was, have you looked at like Critus and Google or Tough or anything like that?
I haven't. I haven't actually delved much in. You mean Critus is there for containers?
No, Critus is like the supply chain stuff. So
Oh, okay.
Exactly what you're talking about. It's Google's solution for it. So.
Oh, okay, no, I haven't. Actually, I haven't even heard of them. But a good shot on the Docker thing. I mean, it did get a lot of attention. Yeah. I didn't look into it too much, and I'm not a guru on Docker. Perhaps if there was a local user or something, then you could escalate up.
No, you couldn't, because there's no way to like SU to root, right? You just
okay.
couldn't change the root.
All right.
Maybe if you like went and installed like SSH and did some video stuff. But I mean, so literally nobody was impacted by that thing at all.
Okay. Well, thank you for clarifying that.
So regarding the access control on both the code and the binaries, one of the problems I've seen come up, and especially Debian's been looking at that, is the reproducibility effort. So the idea that you might be pinning down the code and checksum and everything, but you still can't trust a random binary given, because you have no way to say that binary goes to that code.
Right.
And ideally you would be like this code, you run it, you get this output, sign both, you're happy, and every time you see that binary, you can trust that code. But what we've seen happen, or the problem that could happen, is different code being served to different people. So you see on GitHub, there's the code, it's clean, it looks good, but then when I serve the binary to you in particular, you get a random version. So there's been a huge effort, especially led by Debian, but everyone's joining in, to try to make sure that when you get deterministic build, same code gives same binary, which is ridiculously complicated and very interesting to look into. But the idea that even if we have many eyes looking at the code, makes nothing about the binary is just ridiculous. Even if you were taking in all the advice that you described, it makes it almost meaningless. And that's really hard to take in from a security point of view. Yeah. So, something to think about.
Yeah, it certainly is. I mean, this whole thing is a really difficult and challenging thing to solve and tackle. But as I said at the beginning, it's one that I don't see many people speaking about. There's just been, in the last few weeks, more examples of tainted code and tainted libraries. And if I was an attacker, what a better way to get what I need.
So this leads into a kind of a subject area that's close to my heart. So like as developers, we're encouraged to modularize to smaller and smaller kind of levels, smaller chunks of code. We use like AutoVac and similar tools to lazily put things into runtime. So how do you see protecting against runtime injection of bad DLLs? Is there a way that you've spotted doing that kind of thing?
So there is technology that's called RASP, runtime. Trying to remember what the acronym stands for. Runtime Application Security something. I can't remember the exact thing, but it's kind of, the way I view it is it's kind of like a container, and it actually provides a means of putting controls around your service that's running. So some of the examples that they use, like one example that a vendor used was the Equifax structs thing, how you could actually go in the console and say, hey, there's a CVE for this, put this control around it, and it wouldn't allow that CVE to be executed. So I think the whole industry, I know I hate saying AI and machine learning and that, but kind of the whole behavioral type thing where it can monitor what is a good state and then see when something gets out of their good state and treat that as suspicious and then get someone in to investigate. So, I mean, the only thing for runtime is really monitoring the behavior and then trying to either prevent what's known bad behavior or suspicious behavior and flag it and get someone to investigate it.
Because it's just a really interesting part of a vulnerability. It's
Yeah.
that you could provide a library that has all of the interfaces that everything else would expect, except it's doing something under the hood. It would load it into runtime completely unaware. And the only way of really protecting against that is to really inspect. Well, it's for every library that calls it to inspect some kind of checks and
Yeah.
to do the behavior thing like you're saying. Thank you, it's great stuff. Yeah.
Hey, you're welcome.
Bruce Schneier had an article today about cyber insurance, and he was bemoaning the fact that cyber insurance concentrates on processes rather than fixing the fundamental problem. And if they got around, it's like the thing today about self-driving cars. The insurers are saying, if the person driving the car falls asleep, the car must move over to the side of the road or you won't insure it. Surely the cyber insurance is a way round to get people being more conscious of what they should do for security.
Yeah, personally, I don't like cyber insurance. It's kind of like sticking, or I don't know, cutting your arm and then trying to put a bandage around it, and then doing it again over and over. It's kind of patching a outcome of a bad situation, and it's not going to help encourage companies to do good things because they're going to go, oh well, you know, if I get breached, I'll just claim a payout kind of thing. Yes, there will be clauses in that. Also, the notion around policies and all of that. So if you take PCI-DSS, right, payment card industry, like most card companies have to stick to it, and online retailers and that. One of the things they say is, hey, you must move off TLS V1. They don't give a reason why, but you must move off TLS V1 and move to TLS V1.2. Well, that's a good thing. I mean, TLS 1 is old and needs to, but there's no known vulnerabilities in that. At the same time, they have no stipulation around security headers. And one of the security headers is HSTS. So, host strict transport security. Thank you. And that tells your browser, whenever you visit the site, always use HTTPS. Like you can type in HTTP, your browser will never make a HTTP request. It will always go to HTTPS. Now, PCI-DSS has nothing said about that. So an attacker could still potentially get between the user and the server and do a man-in-the-middle attack. Because they do what's called SSL stripping, HTTPS between them and the server, and then HTTP between the victim and them. That's why I don't like procedures, policies and that, because they're also often very slow to react, very slow to come up to date. Sorry, that's a long way of answering. I don't know if you agree with that or not, but
that's why I asked. I was curious.
About PCI, I guess, a bit of a question. Where you said, yeah, they do specify some of the stuff, but I mean, wouldn't you want to treat that as a minimum of what you need to do rather than the most you have to do to get your application secure? Like all the processes that they mentioned you should have in place.
Right, so if I was taking a view and I looked at those two things, HSTS is going to provide me immediate value. It's going to help do a lot. Moving off TLS1, as I said, there's no known vulnerability, unless you're maybe talking nation states and governments and all of that. Even then, it's maybe, very maybe. I mean, it doesn't make sense. So you're trying to secure someone by not even knowing vulnerability, but you're not saying anything that does actually matter. And that's the problem I see time and time again with compliance and all of that. I don't know who comes up with them, but in my opinion, I think sometimes those people who come up with them aren't technical, so they don't understand some of the things they're coming up with, and some of the things are missing out. So that's where we need better engagement with those who do this thing day in, day out. Hey, what do you recommend? What would make the most impact? Like CSP, MageCart. That was a financial institution. They would have been PCI compliant, and look what happened to them.
So you talked about how updating is like super important, which of course it is, but one could also make the argument that an alternative approach would be to thoroughly security vet a particular version of a dependency, make sure that it matches the relevant security standards and has no obvious vulnerabilities, and then say, okay, stick with this until we have time to vet the newer version. How do you balance the sort of making sure you've got the most up-to-date version against having a chance to actually vet all of your dependencies?
So that is a very good point. So when I say updates, maybe it might be worth clarifying. I wouldn't say go in every day and making sure you stay up to date with the latest library. I suppose I'm so used to the security side where we say update means update patch. Patching means fix the vuln. So that's where tools like OS Dependency Track are really helpful, because you can go to projects and go, right, here's my libraries, these are the known vulnerabilities, and you don't even say, okay, I'm going to fix all vulnerabilities, because you might not always be able to, you might not have time, but you want to at least fix what you deem the highest risk to your organization, your group, or whatever. And that's important to realize. Like, everyone goes, oh, we need to do security, you have to do this. Well, people's appetite for risk tolerance changes from organization to organization, group to group. So it's whatever fits in with you. So if that's what you want to do and you deem that acceptable, then I'd recommend that. Personally, I try to move everything to the latest because I'm paranoid, but yeah.
So in a sense of, as you say, monitoring your software dependency, I mean, a lot of companies are picking up some of these scanning tools like something like OpenVAS, for example, and relying on a bare knowledge of what it's capable of to scan their system and say, well, this looks like it's in a reasonable state. Okay, it may not have enough effort in the company to directly audit everything that's there. And would you say that was a reasonable practice?
I mean, it's difficult to say. I can see it from both angles. So it is a difficult task. And at the end of the day, I think most companies, if not all companies, are challenged by resources. They only have a finite number. So it's all very well saying, hey, you must do all the security stuff and do all this development and do it by yesterday kind of thing. And that's where I always say it's a balancing act. And it comes to the risk appetite. Do what you feel is acceptable. If you're unsure, ask. Ask some of if you've got a security department, ask them. If you don't and you're small, Twitter is a great resource. People are always willing to help out and provide you advice and guidance. There's also loads of resources. because the thing to consider as well when you're making that decision is, and this is why security is so difficult, is the attacker just has to get it right once. You have to get it right all the time. And that's what makes it so hard and painful.
Any other questions? Well, thank you, Sean.
Cool, thank you.
So with that, we conclude our event for this month. What we're going to do is, well, what we usually tend to do after the event, we go to the pub at the end of the road, Blue Blazer, if you want to come along. I don't know if there's still pizza left, but yeah, hope you all enjoyed the event tonight, and if you did, we're going to be on here again next month, second Wednesday of the month, so hopefully you'll come along. Thank you.
Thank you.